I should probably not watch scary movies while I'm working here alone. I just think that's not a good idea. Anyhow, let's talk about standard form one more time and kind of explain to you what you might use standard form for. So a lot of times I'll have a problem where I have two different amounts of something and two different types of things. And I can set up a relationship between those things if I can write the rate times the amount plus the rate of the second item times its amount, and that is usually going to equal some total value, okay? So if you can set it up like that, you can use standard form. So if you look at the first example here, it says suppose you go to McDonald's and buy cheeseburgers for $2.50 each and fries for $1.75. The total you spend is $22. So how would I set that up in an equation? Well, if I say let x equal the number of cheeseburgers, and I could say y is going to equal the number of fries, then I end up with $2.50 for one cheeseburger, but since I have x of them, it's $2.50 times x, and that is the total money that I pay for the cheeseburgers. Plus, well, if y is the number of fries, if one of them costs $1.75, all of them would be $1.75 times y, and that is the total money I spent on the fries. So if I take the total money I spent on the cheeseburgers and the total money I spent on the fries, I get the total money I spend overall, which is 22. So I had a rate times an amount, rate times amount, and then my total. Okay? So now let's look at the next one. And by the way, sometimes it's not the amount that's unknown, and that's what we're going to see in the next one. It says I buy 5 DVDs for a certain amount of money, and I buy 7 for a different amount, and I spent $99.88 total. So how would you set this up as a linear equation? Well, I will let x equal the value of one DVD, or the rate that you buy it at, you could say also. And I will let y equal the value of one Blu-ray. Okay? So I have 5 DVDs. Each of them has a value of x, and I have 5 of them, so it's 5x. Plus, I have 7 Blu-rays. Each of them has a value of y, so the value of all of them would be 7 times y. And the overall total value, I was told I spent $99.88, which is a lot of money. I actually did spend that much at Best Buy once on videos. It's not a good thing to do. You need to save your money. So the rate I didn't know this time, times the amount, rate times amount, and total. And that's how it works, okay? So let's try the last one. It says the theater sells adult tickets and children tickets for these prices. Total ticket sales are $7.30, and I guess I need to make that dollars because we're talking about dollars. I don't want you to think that's the number of tickets I sold. That's the dollar value of the tickets. Okay, so I do not know the amounts of the tickets, so I will let x equal the adult amounts, and y will equal the child amounts. I should put the word amounts in there, right? Okay, so one ticket for adults is $7.75. Since I have x of them that I sold, altogether my sales from the adult tickets were $7.75 times x. Plus, one child's ticket is $6.50, but there were y of them, so it's 6.5 times y. And that should give me the total sales of $73.10. And once again, you have a rate times an amount, rate times amount, and then that gives you some total, okay? So also remember one more time, sometimes it's the rate that you don't know, like it was here when I didn't know the price per DVD. Sometimes it's the amount that I don't know, like it was here, and like it was here when I did the McDonald's problem. Now, we haven't actually solved those problems yet because there could be many combinations of x and y that make those equations true, but we will learn how to solve things like that in the next chapter. For right now, we just want to be able to set it up. So talk to you again soon.